Howdy. Today we're working on an old antique fan that has a switch that is failing, and apparently customers already had this worked on once or so in the past. It's not a switch you've ever seen before. I'm going to show you here in just a minute, and we're going to fix this. We're going to actually fix it right. Tempted to change out the switch with a different one, but I would love to keep this thing original. So let's see what we can do. All right, so this is the fan. It's an old Mathis Cooler 4-speed fan. All right, nice metal blades, wooden box. This is really cool. See, nice stuff. Louvers you can adjust, you know. They're aluminum, I believe. And nice good old motor. But here's the switch. It's funny, the switch goes right up here, okay? And normally it's got the shaft sticking out like this, okay? And the shaft button is right here that goes on it. But this is the switch. Check it out. It's actually a transformer. Pretty crazy. And if you see this, the way this guy works is when you turn it, it has these brass little tabs that stick off. Here's one, and here's one on the other side. This one's shot, and they make contact with these little buttons here on the transformer, okay? So when you turn it, you have all the way from the off position here, and then you got high, speed 1, speed 2, and low. Oh, off would be all the way over here. Sorry, there's off. And the way it works is underneath here, the transformer has, you got power coming to it from your AC power here, and it feeds it in, and you can see these different windings come off are going to be at different levels of power, basically. This is not a switch like they make anymore. It's really pretty cool. So what I'm going to do is I'm actually going to try to repair these brass pieces. I got some brass from my local hardware store, some shim stock here, and I'm going to take this apart and I'm going to try and make these little guys. Let's see what we can get. All right, I've got the screws off and I took this bracket off, okay? So now it's obviously going to come apart, but what we've got here are a couple of these little basically ball bearings or little rollers that go in the slots here. That's when you turn it, it actually kind of goes in between the bumps, and that's what keeps it in place. So you click, click, click. So those are important little guys, which are going to go in these little pieces right here, okay? Just like little wheels in a housing. Now I'm going to take this apart, and this should slide off. I may have to get a, yeah, it looks like it might be a snap ring or something, so I'll take some care to take this apart here. Okay, it actually just, this brass piece just pops off the bottom. Just kind of wiggle it. Okay, there we go. Got a washer here. Got this spacer here. All right. And now what the tricky part is going to be is somehow, this is riveted, so I guess I was hoping they were just clamped, but they're actually riveted in here. So I may be able to do something with this. I'm not sure. I'm going to look at it and work on it. We'll figure it out. So I'm looking at this, and this actually may be copper. It may not be brass, which could be an issue because copper, I think, can handle a little higher temperature. I'm not sure. I need to research that. But I have these little tabs I got from a hardware store, which I might be able to put in there. Like if I can you know, grind off this rivet. I have some rivets here that might work. Of course, these might be aluminum. I think they are. I'm not sure if that's going to be an issue, electricity going through it. Aluminum typically can conduct a lot higher electricity, so we might be okay. I'm going to do a little research. I'm going to check a few things here, and maybe I can put these rivets in there if I get the rivets removed. It's like a sandwich here. We've got this board, like a non-conductive, like circuit board material here, fiber board. Okay, and then the layer of this metal, and of course then another insulated circuit board area, and then the top layer of metal, which is actually, this is the right way, it goes that way. So I'm gonna do a little research and figure out how to get this thing fixed. All right, it looks like the brass will be just fine. Copper is a better conductor than brass, but brass will hold up a little bit better, and I think that might be, as far as mechanically, that might be better in this situation where these little pieces of brass are dragging back and forth across the bumps of this switch. So we're going to try it out. As far as aluminum goes, like these rivets, it should be fine because aluminum is not as good, again, as copper or brass for electric conductivity, but this, where the rivets are going to go, is not really a conductor. Well, let's see here. Let me look at this. It looks like it is going to be a little bit of a conductor, but I think we're going to be able to do this, so we'll try it. So I'm going to basically file off this part of the rivet here. This side is bigger. This side's the ring part. So I'm going to file these off so I can take this apart. That's what I'm doing next here. Okay, I got the rivets out. Obviously had to file down the edges of them and then carefully pop this off, and then again file the edges and pop that off. This little centerpiece came out. I'm not sure if that was already, it's a nice round circle, so I'm not sure if it was already like that or not, but oh yeah, it was, because I can see this one. But okay, so I'm putting it back kind of in order. And then this guy was next right there, and then this one was the last one, and I had to file the rivets off so that I could pop it out. So a little intricate, but this looks brass. Actually, these look brass, so if I had brass rivets I'd use them, but I think I don't, so I'm gonna just use these aluminum. Hopefully they'll fit through the hole. We'll see. If not, I might have to get some brass rivets. Yeah, so it looks like these rivets will fit through the hole. It's a tight fit. Looks like it'll work. Let me try it with the other parts here. Yeah, that should fit. It's going to be tight, but I think it'll work. I may have to ream these holes out just a tiny bit. Okay, so these little pieces I'm going to use here, they have a dimple right there that I'm going to, I guess you can't really see it, I'm going to have to drill out that hole so it'll line up with these other pieces. I tried to just drill it. I put this in a clamp, tried to drill it, and the drill bit's walking, so I'm going to have to punch it to try to get it, you know, started here. So let's try this. I don't have a punch, so I'm going to use a little Phillips. See if it helps. See if that's sufficient. Okay, I was able to successfully drill a hole in one of these little tabs here. Okay, and now this piece I ended up cutting. So this piece here was the old piece, and this is a good part of it. This part's not. This part was destroyed, so I ended up cutting this piece off because this little brass piece is going to end up going right about here. So I'm going to go like that. So we're going to try that. We're going to put it together and see how it works. Okay, so I was able to get this piece in there, and I was able to rivet this back together. I bent the new piece, the new brass piece, similar to the other side. So what we're going to do is we're going to put it back together and try it. And in the meantime, I went ahead and used some emery cloth and sanding paper and cleaned up these contacts. So we're going to put this back together and see what happens. Okay, so I got it together. I had first actually riveted it together with this plate upside down. See how it's dipped there for the little axle for the rollers? I had it flipped the other way, so that wasn't going to work. Anyway, I took it back apart and try it again now. So let's see if we can get this together. Okay, I was successful in getting this back together. It was a bit of a pain, but put it all back together so that my little rollers are in the grooves, and my copper, thin piece of copper here is in place. I used the existing one because that one was still pretty good shape. And then this is my newfangled little piece I made out of brass. So now when I turn this, that's off, okay? There's the first position. Second position, third, fourth, which basically we got off, high, what was it? Where's my little thing here? Okay, here it is. So we have off, then we have high, then we have, I don't know what that is. 1, 2, low. I don't know. 1, 2, low. So I would imagine it's going to be high speed, next to high speed, medium low, and then low. That's where we're at. So I'm going to put this back together and we're going to test it out and see how it works. Okay, so the fan is back together. I've already tested it once before I put it completely back together, but now we've got our switch here. I'm going to go ahead and it's in off. I'm going to put it to the high.
Well, there we go. Got the fan fixed. It's working good, and I'm going to be giving it back to the customer tomorrow. I think they'll be happy about that. It's a nice antique fan, and it's pretty much in original condition. So you guys have a good one. See you next time on the Handyman channel.